All right, number 11 through 13 deals with this diagram right over here to the right of the page. So let's look at these and see what they say. 11, find WZ if WX equals 9. Find WZ, that's this whole thing, if WX equals 9. We have a theorem that says if it comes from the center, we're assuming that R is the center here, radius that comes from the center that is perpendicular to a chord cuts the chord in half. So if WX is 9, then the whole thing, if WX is 9, then the whole thing, WZ, would be 18. We'll go ahead and do 11, 12, and 13 on this one video. Find SV, this whole thing, find this whole chord. If RX, R to X, that's this segment right here, equals RT. Right off the bat, I have a theorem that tells me if the chords are equidistant from the center, in other words, if from here to there is the same as from there to there, or if RX is the same as RT, which this tells me it is, then these chords, chord WZ and chord SV, are congruent. Okay? So WZ is 4x minus 16, and SV is 2x minus 4. I just need to find SV. So those are congruent, so I'm just going to set them equal to each other. 4x minus 16 equals 2x minus 4. That's going to give me 2x equals, it's going to be equals 12, x equals 6. So if x equals 6, I know that I have to find SV. If SV is 2x minus 4, that's going to be 2 times 6 minus 4, 12 minus 4 equals 8. So SV would equal 8 units, whatever those units are. And then lastly, find RY. RY, that's this whole thing. That's a radius. RY, it's the radius. If WZ equals SV, okay, the chords are the same, so that means from there to there, for RX and RT are the same. All right, RX from here to here is 10. TV from there to there is 15. Okay, from there to there is 15. So let's do this. All right. I'm going to have to draw an extra line here. Let's do this. Let's draw that line in because I know TV is 15. That's this length right there. I know RX is 10. If RX is 10, RT is 10. And I need to find RY, which is a radius, right? But if I find RV, that's a radius as well. RV is the same as RY, okay? RV equals RY. So let me just find this. All right, this is a right triangle, so I can use the Pythagorean theorem. All right, I'm just going to plug it into my calculator here. All right, I'm going to do the quick way. The square root of 10 squared plus 15 squared. The reason I can do plus is because I'm looking for my hypotenuse. If my hypotenuse is one of them, then I'm going to do the square root of the hypotenuse squared minus whichever other side we know, and that's going to give it to me, right? Oops, wrong button. Let me try that again. Square root of 10 squared plus 15 squared equals, I don't know where my expressions are. Here they are. Equals 5, if I look at this, all right, 5 square root of 13. I can just do that. 5, ooh, that looks like 5 square root of b. 5 square root of 13, or if I want to write it as a decimal, that's going to be 18.0, right? Or 18.0. That was my third side here of this triangle using the Pythagorean theorem. That, I can say approximately, this side is the same as that side. So, right? That was number 13, 11, 12, and 13.